So as we move on, we're now going to be looking at Venn diagrams and how they can be useful in grouping events together for us to go ahead and find probabilities. They're a very visual way to represent the combination of different events. So a Venn diagram is also a nice way to represent a sample space. And here we'll make a Venn diagram for the outcomes you get when you roll a dice. Here's all of the individual outcomes. And we know an event is a group of outcomes. So the event of rolling an even number is going to be all of these even numbers, and we can just ring those off together, and that is the set of even numbers as you might get when rolling a dice. The event rolling a prime number will do a similar thing. We can just circle off all of the prime numbers, and this is the set of prime numbers you might get when rolling a dice. Some things don't belong to any of those two events, don't belong to any of those two sets, and they'll just be outside of the rings, but inside of the rectangle. So when we're dealing with sets or multiple events, using a Venn diagram is actually a quite useful way to visualize what's happening. So here's a few diagrams and some terminology just for you to be aware of. The events A and B happening, or any two events happening, we refer to as the intersection of those two events. Now, A and B we'll refer to as the intersection. There are multiple intersections, but this is the principal intersection out of all of those. Event A or B is known as the union of A and B. It's not as strict as the intersection. You're allowed to be just one of the two events. You're allowed to satisfy just one of them, and you'll be included in the union. Whereas for the intersection, you have to satisfy both. So if you have a look, we'll see that the intersection is usually smaller than the union of two individual events. Next, we have the event not A. As you can see here, this is everything outside of the event A. It's the opposite of event A. We refer to this as the complement of A. And we can have multiple combinations of these, and you'll come across these in time. It's important that when looking at a Venn diagram, you can use the grammar, you can use the clues in the text to know exactly which regions we're referring to. Okay, let's try and draw a Venn diagram. In this particular question, we're working with a deck of cards. So I've mentioned before that there are 52 cards in all, 13 in each set. We've been asked to draw a Venn diagram for two sets, the aces and the diamonds. So first we're going to start with the middle. We're going to start with the intersection. Is there anything that satisfies both of these events? Well, there is one card which is both an ace and a diamond. So we can fill that in with 1. From here, we can move on to one of the other sets. What about the aces? There are 4 aces altogether. So the circle for A needs to contain a total of 4. I already have 1, so I need to fill in the rest of the 3 aces. So let's just check that the circle for A still adds up to 4, and I'm still representing my 1 ace that was also a diamond. There are 13 diamonds in total. The circle for D needs to contain 13. I already have 1, so I need to fill in the other 12 diamonds. And they will go inside circle D, but remain outside of circle A. Okay, a lot of people at this stage think they're finished with the Venn diagram, but we should always check to see whether or not there's anything or there's any outcomes that are on the outside of both of these sets. There are 52 cards in the deck. So far, I've only accounted for 16. There's another 36